Okay, so the structure of the internet. This is the best sort of image I could find to try and highlight how it works. There are international links that join different parts of the world. So you've got like the cables running under oceans and things like that. Then once you get to a part of the world, let's imagine this was Europe. You could imagine different. These nodes here might represent different countries, and then within that, you would then have different localities like counties and things like that. And eventually you get down to sort of the university campuses, the local area networks, school networks, etc., until you get to an individual user. But obviously, we're talking about millions of connections here, not just the few that are listed here. So you need to think this is tried to be significantly simplifying it. And here it's saying, look, within each of these green sections here, it's trying to just highlight these are the huge continental and national backbones. So these are huge, really important connections. But if one of these dies, there are still routes to get everywhere. It's just they might be slightly slower. Okay, but the idea is there is some sort of, I describe it as a hierarchical structure to the internet. And I've said here that Europe, Africa, the Middle East, North America, Central and South America, the Far East and the Pacific are all linked by very high-speed connections, which form the core backbone of the internet. So there is the core backbone, but it's not like on a bus network topology where you cut the backbone and the network dies. It's just you cut the backbone and the network slows. Okay, the internet is something that is almost unkillable now. So that is kind of the idea of the structure of the internet, and it's built upon a couple of key principles. So if you imagine that you could also view the internet like this, okay, so while there are like some sort of hierarchical structure to the links and things like that, you could view it like this. There's just loads and loads and loads of different nodes and different connections. So if you've got one point here and you want to communicate with that point there, you could say that could be England, that could be Australia, whatever. You could communicate across to that point via lots of different links. And the key ideas that make this work are these three below. So you've got redundancy, this idea that there's so many routes that data can travel down to reach its destination. If one's cut, the connection can still be there. So this idea of redundancy is really important to the internet. The next one I think is the most important is end-to-end communication. So this is the idea that communication between two devices is established and maintained by themselves. We'll do more on this later, but what we mean is if X wants to communicate with Y, X and Y are the only two people that establish and maintain that connection. So they'll talk to each other. There are people that can monitor the connection, the people that you rent your internet off, the ISPs, the internet service providers, they can monitor it, but essentially this is the connection that is taking place and it's maintained and established by X and Y. The need to not have anybody else interfering or reliance on anybody else is a key point of the internet, because there's billions of connections going on all the time. To have to rely on another company or something else for it to work would be a massive fundamental flaw. So for these X and Y to communicate, it's only reliant on X and Y. And finally, packet switching, which we're going to do more on both of these points later, but just this idea that data is split up into packets and sent across the network via different routes potentially, to try and ensure that if one packet gets lost, you don't have to start all over again. So packet switching, redundancy, and end-to-end communication are three of the fundamental pillars of the internet.